Good day, madams, and all the friends are listening. We are Group 13, and I'm the leader, Quah. Today, we are going to perform our TCN project, which is planned to design a secure and efficient network for newly established IT companies. So, first of all, let us introduce the people beside our TCN project, which is Chong Yusin, Chang Kenji, Wong Jieteng, and I. In our group task distributions, we are planning Kenji and I to complete the design topologies, IPv6 configurations task, and ensure the whole network can work under the project's requirements. For the report and testing debugging part, our group are also planning using and to take a good care also. So first of all, let's coming next to our contact overviews for our presentation video. It will be separated into the four parts, which are the project's overview, networking topologies, IPv6 configurations, and verify the connecting from a device to a device. In the last, we will also perform the server verifications also, which are including the file servers, web servers, and these DNS servers as the main. So first of all, the projects are focusing on design a secure and efficient network for a newly established IT company, as I say. So the network will be support the students' lab, the administrative office, and teaching staff will ensuring the seamless communications, resources sharing, and the control internet access. This implementation will be done using our Cisco package tracer as our group using. So coming next is our group objective. So we plan to aim these objectives, which are design a secure and scalable network to ensure the communications between device to a device. Number two is set out the network components that are needed in the projects, which are include the file servers, web servers, and more and more. So at the last, we are also planning to optimize the performance and security through the subnetting and the routings. So that's all for me. And coming next is our networking topologies. Thank you.
Hi everyone, I'm Wong from Group 13. Today I will discuss the network topologies and security password configuration parts. Let's start with the logical topologies. This refers to how data flows within a network, regardless of its physical design. It includes the arrangements of device, node, and connections in a way that define the path data takes. Key component includes switch, router, and the protocol that govern data transmissions. Key aspect of logical topology is include data flows, how information move between devices, network protocols, rules and conventions for communications, addressing schemes, IP address and subnetting, virtual LAN, segmenting network traffic for efficiency and security. Next, physical topologies. This refers to the actual layout of Internet, including the physical placement of device and the cabling that connect them. It's the physical parts of the network infrastructure. Key aspects of physical topology is include device placement, location of router, switch and server, cabling, type of cable used such as Ethernet or fiber optic, network hardware, physical device like hub, repeaters and access point, redundancy and failover, ensuring network reliability through backup connections. While the logical topologies focus on data flows and protocols, the physical topology deal with the actual hardware and connections. Both are essential for a comprehensive understanding of the network. The logical topology can change with software updates, whereas the physical topologies require hardware changes. Now I will be presenting the budget for our project. Our project will cover the key part of budget, including the cost of router, switch, PC, server, and other essential equipment. The total budget for this project is 219,341.20 ringgit. This budget covers a range of products including network equipment, computers, and cloud service. We have allocated 1,456 ringgit for router, the TP-Link Archers AX10 AX 1500 Wi-Fi 6 routers. For switch, we have chosen the D-Link DGS 105 5-port switch with a total cost of 735 ringgit. Additionally, we have budget 1,126.26 ringgit for TP-Link AX 1800 wireless access point and 65.66 ringgit for Cisco DPC 3010 cable modem. The largest portions of our budget is allocated to PCs with a total cost of 194,326.28 ringgit for 72 units of a Dell Experience 24 all-in-one desktop. We have also budgets 14,232 ringgit for 4 Dell PowerEdge T620 tower server. For mobile computing, we have included one Dell Experience 15 laptop at a cost of 2,399 ringgit. We have allocated 5,000 for cloud service. Our project budget of 219,341.20 ringgit cover all necessary equipment and service. Most of the budget is spent on PCs and server, showing that we need strong computing powers. We also spend a lot of networking equipment and cloud service, which make it easy to connect and manage data. That's all of my parts. Thank you.
Hi everyone, I am Chong and I will be presenting the verification of connection between the devices in our project. So for example, we will be pinging Lab 1 PC3 from Lab 1 PC16. So from here we can see that we will be pinging from Lab 1 PC16 and we will be pinging Lab 1 PC3. So here we just go to PC16 desktop and command prompt and then we type in ping and then we take a look at PC3 IPv6 address and then we just type it in. So once we have done type the IPv6 address of PC3, we just enter and then we will see replies from the packet transfer and then we will see that there is a 0% loss between the transfers of PC16 and PC3. So we have proven that there is connectivity between these two devices. So next off, let us go to Lab 2 PC9. From there, we will be pinging Lab 2 PC23. So so here we will be at the command prompt of PC9 and then let's take a look at PC23 and the IPv6 address. So for the same thing, let's just type in ping and the IPv6 address of PC23. So just enter and then we will see replies of the packet transfer and then 0% loss of the transfer between PC9 and PC23. So it has proven the connection to be successful. Next, let us have a connection verification between sysadmin PC1 and admin PC3. So here we will be at the command prompt of sysadmin PC1 and then at admin PC3 we will be looking at the IPv6 address. Same thing, let's just type in ping and then the address. Okay, so now we've done typing everything. We will see that there are replies between the transfer between sysadmin PC1 and admin PC3. So 0% loss, same thing. There is connection between the two devices. Moving on, let's go to the transfer between class PC1 and lab 2 PC13. Is right here. So look at the PC13 IPv6 address over here. Let's just type in ping and the address. Same thing, we have seen replies between for the exchange between class PC1 and PC13. So this has also proven the connectivity between the two devices. We can see that there is 0% loss between transfer. Now, lastly, let us just ping class PC2 from tutor PC4. Right, so let's just look at class PC2 over here and then let's just type in the IPv6 address. in the tutor PC4 command prompt. And then we have seen the replies between the exchange of class PC2 and tutor PC4. So 0% lost, and this has also proven the connectivity between these devices. So that is all for verifying the connection between the devices in our project. Thank you.
Hi, my name is Chang Tianzi, and now I will be demonstrating the accessibilities from PCs to the servers. For Lab 1 PC0, we're going to go to the web browser and we'll be entering mu.edu.my, and it shows that we are successfully connected to the web server. Let's say we choose another PC, system admin PC0, go to the web browser and we enter mu.edu.my, and it will show the same result. As for FTP server, we're gonna choose another PC, let's say laptop. We go to the text editor, we write a file, let's say hi, we save the file as test.txt. Now we go to the command prompt, we enter FTP and the IP address of the FTP server. Now we log in to the FTP server. Now we're gonna use the command put test.txt to the FTP. This file is successfully entered in the FTP server, so we can check it by entering dir. As you can see, test.txt is in the FTP. So now we're gonna quit this and choose another PC. Let's say class PC0. We go to the command prompt. We entered FTP and the IP address of the FTP server. We log in to the FTP server. Now we're gonna retrieve the text file by entering get test.txt and then enter. Now we're gonna quit and we're gonna go to the FTP service, and as you can see, test.txt is in our file. Now we're gonna choose another PC. Let's say lab 2 PC0, and we go to the web browser and we enter www.google.com. As you can see, we are successfully connected to the ISP server. Now we can choose another PC, let's say admin PC0, go to desktop, web browser, and we enter www.google.com. As you can see, it shows a request timeout message as it is restricted from connecting to the internet. That's all from me.